what is given here? A Kaplan turbine working under a head of 15 meter. Head is given working under a head of 15 meter develops 7300 kilowatt shaft power. 7300 kilowatt shaft power. The outlet dia of the runner is 4 meter and the half dia is 2 meter. So outlet, that is D naught, is given 4 meter and DH is given 2 meter. The guide vane angle at the extreme angle of the runner is 15 degree. That is, your alpha is given 15 degree. Okay. Then hydraulic efficiency is given 90%. Overall efficiency is 85%. Okay. And what is given, if the velocity of the wheel at outlet is 0, determine. What it says, the velocity of the wheel at outlet is 0. That means your VW1 is 0, is given. Okay. And when VW1 will be 0, your beta is equal to 90 degree. Okay. So it's giving in a different way. Okay. In previous case, if you see, they have directly given that the radial flow, that means your beta equal to 90 degree. Here in a reverse way, they have given that velocity of the wheel at outlet is 0. That means your VW1 is 0. That means when VW1 is 0, when your beta is equal to 90 degree. Okay. So determine, that means what it says, if velocity component of wheel at outlet is 0, determine the runner vane angle at inlet and outlet, runner vane angle at inlet and outlet, and also the speed of the turbine, that is N. Okay. And also the speed of the turbine. Okay. So we have to find out the angles, vane angle at inlet and outlet at the extreme edge of the runner, and we have to find out the speed of the turbine, that is N. Okay. Okay, now we are move on to the solution. Okay. So first we draw the diagram. So it's very much similar. 15 degree, alpha is 15 degrees given. Theta is not known to us. Here again beta is equal to 90 degree. If beta is 90 degree, your VW1 is equal to 0 and VF is equal to VF1. Sorry, not VF1. VF1 is equal to V1. Okay. So phi and theta we have to find out. Okay. So H is 15 meter given, alpha is given, VW1 is 0 given, outer dia is given, half dia is also given. Okay. Hydraulic efficiency given, overall efficiency is given. So overall efficiency is equal to shaft power divided by water power outlet at inlet. Okay. So shaft power by water power. So you just write down the equation. Overall efficiency. So shaft power is already given 7300. It's given in the question, okay? Rho GH Q divided by 1000. Okay, so here overall efficiency is given, sub power is given, rho is equal to 1000, G 9.81, H is 15, discharge is not known to us. Okay, divided by 1000. So from here you can easily find out the discharge value. Find out the discharge and see you are getting the same value or not. 58.36 meter cube per second. And then we are going to use the discharge equation that you have already wrote. Q is equal to pi by 4 d naught square minus dh square multiplied by Vf. Okay. So here discharge we are going to use 58.36 pi by 4 d naught. That d naught value is already given in the question, that is 4 meter, and dh is also given, that is 2 meter. Okay. So you substitute here and find out the Vf value. Why we are finding Vf? Because to find out the theta, if we take this smaller triangle, if we take this smaller triangle, this is angle theta, this is Vf, okay, and this base is nothing but your Vw minus u. Okay, this part is Vw minus u. So to find out this theta, we have to take tan theta Vf by Vw minus u. So to find out theta, we should know what is the value of Vf, Vw, and u value. Then only we can find out the angle theta. Okay, so that is why first we have calculated the discharge value, then we are using the discharge equation and find out the Vf value. Okay, using the discharge equation we will find out the Vf value, that is 6.19 meter per second. 6.19 meter per second. over 6.19. So VF is nothing but your velocity component, that vertical component, okay, vertical velocity component. So that's why the unit will be your velocity unit, meter per second, okay. So after that, we need to find out the U value, okay. Okay. So, so the parameters we need, VF we have calculated. So we need to find out VW, okay. So for VW, we are going to use the larger triangle, VF, VW. Angle is alpha is given 15 degree, 15 degree, okay. So you take 10, 15 degree is equal to VF divided by VW, okay. From there, you can find out the VW value. So 10 alpha is equal to perpendicular by base. Okay. So with this equation, you can find out the VW value, and this is also unit of meter per second. 23.10. 23.10. Okay. Then we are going to use, because we need three components to find out the theta value. One is VF, we have already calculated. Second is VW, because for the base, in the triangle, for the base, we have to find out VW minus U. Okay. And here is VF, and this is your theta. Okay. So to find out theta, we need these three components. Okay. VF we have already calculated. VW is also we have calculated. What is left out with U. Okay. To find out the U value, we are going to use hydraulic efficiency, as hydraulic efficiency is given to us. Okay. So you use the hydraulic efficiency equation, VWU divided by GH, as VW1 is 0. This is also given. Okay. If this VW1 is not 0, then this equation will be different. Okay. As VW1 is 0, that's why there are some components is missing. And the left out component is VW multiplied by U divided by GH. Okay. And from here, your hydraulic efficiency value is given 90%, that is 0.9. VW we have already calculated 23.10. U value we need to calculate, G 9.81. H is also given 15 meter. Okay. So from here you can find out the U value, that is 5.73 meter per second. So next we need to find out the theta value. Okay. So we are going to take 10 theta. We are going to take 10 theta equation, and other all the terms are known, so we can directly find out the theta value in terms of degree, that is 19.61. That is 19.61 degree. Over. You are getting the same value. Okay. So one angle we got, another angle we need to find out, that is phi. Okay. So for that also we are going to directly find out the 10 phi. So VF1 is equal to VF. Okay. This is assumption. VF1 is equal to VF and U is equal to U1. We will consider that speed of the vane will remain constant. Okay. So these two are the assumption for the turbine. Okay. One is VF and VF1 are same, and second is U and U1 is same. Okay. So for 10 phi, you can use this equation. VF1 and U1, the upper triangle. Okay. This is your VF1 and this is your U1. This is your angle phi. Okay. So we take 10 phi perpendicular by base. Okay. And you find out the phi value, that is 47.21 degree. 47.21 degree. Done. Okay. So at last, again, we need to find out the speed of the turbine. Okay, that is N. So we are going to use this equation pi d naught N divided by 60. Okay, here pi value is known to us. N value we need to calculate. D naught is given 4 meter divided by 60. Okay, U value we have already calculated. So from here you can directly find out the N value, that is 27.36 rpm. 27.36 rpm. Okay, so we have almost completed our syllabus. Okay, so I'll share with you some PDF file. Okay, related to turbines and one or two PDF file for penstock. Okay, so you kindly read it out. Okay, and in the next class we will I'll give you some practice numericals. Okay, and some practice questions also. I'll share with you. Okay. So these documents I'll share with the seer and I request here to kindly circulate among all the students. Okay, I think that CR of section A is not present, right? Is she present? Section B, I'll give it to Himal. Okay, Himal, you kindly circulate with all the students. Okay, okay then. Uh, these documents I'll share with the CR. Okay, both the CR from both the section, and they are going to circulate with you. Okay, thanking you. So see you in the next class.